why and how did we start our attribution journey? We've listed quite some remarks and questions that we got over the past, 3-5 years from across the business, finance, e-commerce, online marketing, CRM, and so on. I guess many of those questions are questions that you guys also receive or have received in the past or ask to the analysts. I won't cover every one of them, but they vary from how much value did our Google Ads campaign deliver, how many revenue do you get from organic traffic, what's the cost of sale for every marketing channel, how should we allocate our monthly budget across all the marketing channels, and so on. On the right, you can see some of the requirements that we get from the marketeers mainly. They say last click attribution is insufficient, existing DDA attribution from our tool stack is unstable, and they would like to have attribution automated and connected into every advertising platform that they use. So we took those notes and we tried to evaluate what kind of solution we could offer to them. We saw that indeed the existing tool stack was insufficient, so we started building our own in-house attribution model. Before really starting, we took one step back and looked at how this would fit into our data and measurement framework. You can see the data framework that we try to achieve. In the middle, you have the centralized customer data platform that is being fed by 3 types of data. First one is business data. For us, the margins, empty seat and bed bank costs, and product information are important. Second one is user and customer data. There are many examples, but we just highlight first and third party data, then the anonymous user data, so mainly GA4 in this case, and then of course some data science recommender engines. And then the third one is media effectiveness data. Spend, traffic, revenue, cost of sale, ROAS, and so on are important, and of course the diminishing return curves. So this is the data framework that we try to accomplish. If we zoom in on the media effectiveness part, this is being delivered by our media framework. It's a pretty straightforward one, well known. It ain't rocket science to understand, but we have MMM on top, media mix modeling. It's basically a macro level analysis of the on and offline marketing channels together with external factors, and you try to evaluate the impact on sales. Next to that, we have incrementality or lift studies. This is a causal incremental impact analysis where we estimate the impact of a certain marketing activity. So for example, you do a split test, meta advertising versus non-meta advertising, and you see how many incremental sales you get by doing meta advertising. And then the third one, MTA, or multi-touch attribution. This calculates the value of individual touch points, in this case, online marketing channels, and you try to estimate how much value those individual touch points have to your sales. So as mentioned, it's an easy framework, but it's really difficult to calibrate these 3 together. Individually, it's doable, but to really have one framework is really tricky. And only then you can have marketing effectiveness. So basically making sure every marketing dollar you spend is being spent as effective and efficient as possible. For now, we will just continue with zooming in on attribution.
Yes, thank you. Attribution, it's a pretty complex thing, and we have a solution for it. We've thought up of a solution, but we tackled how are we going to do this and why. First of all, we all know the big tech marketing platforms, they're going autopilot. Small references to our business. But to do the pilots, we know where the plane is going. Because as you can see, every platform is using their own compass, their own destination. And I think when you're on a plane, you know you're flying autopilot, but it's also a nice thought that the pilot actually knows where the plane is heading. And that's why we decided to try and build our own compass, our own destination to fly to. Because everything these days, all Google Ads products, everything Facebook, it's all smart, it all has AI embedded, and it all works somehow. We don't know how, we don't know why, but it works. But still, it all goes to a different direction, according to the different channels. So that's why we decided, by connecting and modeling a lot of our data, we wanted to build our own source of truth, our own compass, and our own destination, so that the pilots know where they're headed. And for our attribution solution, we had set some requirements we had to fulfill before choosing it or building it. The first one is we had to be able to combine different data sources, mainly web data, of course. We want to know what users do on our website, but also maybe CRM data or business data, such as pricing and yielding information or product data. The second one, yeah, I think this room will probably agree, but it had to be data-driven. We didn't want to make decisions based on emotional stuff or anything else. Third one, it had to be end-to-end and with different layers of granularity. So end-to-end meaning from the data collection parts up until the data processing and the data analyzing, and the activation, of course, and on certain levels, so on a channel level, maybe campaign level, maybe even deeper. And it had to be fully automated, of course, to gain optimal efficiency. And in the end, we wanted it to be able to connect to as much of our marketing platforms as possible. So it's easy to use, and we have no effort on it. But you all know that attributing revenue is pretty complex. We have a lot of different possible customer journeys, a lot of different types of users who come to our website via different devices. There's laptop, tablet, and mobile. And also they come to our website via different marketing channels, also maybe direct, but yeah, we've listed some of the biggest ones, Criteo for retargeting, Google Ads, Facebook, Instagram, you all know them, but there are a lot more, of course. And there are different outcomes when they come to our websites, mainly whether they make a transaction or they don't. On this slide, you can see some examples of customer journeys that we see on our website, and you probably all know. So maybe someone clicks on a social ad on Facebook and comes to our website on their mobile phone. Later they do a Google search and they land on the website on their laptop. And then they get retargeted with another ad. And eventually they make a purchase. But how much value do we attribute to which touch point? It's mainly the biggest question in the attribution question. And it's causing you, of course, the attribution hangover. Now getting to the hangover, in the past, the big platforms advocated mainly like single-touch heuristic models for your attribution. But they fall short and they fail. They're not telling us the truth. And I'm going to show a quick example why they're not telling us the truth. First quick question, show of hands. Who is going to the cocktail hour at 5 tonight? All right, and who's going to the Halloween party? Now think of this as the customer journey of tonight's cocktail hour following the Halloween party. So we start with a cocktail, then we go to the Halloween party, have a few beers. Then of course there's always the one guy, haven't found him yet, but that comes with a platter of tequila shots. Then maybe a glass of wine, and before we get back to the hotel room, little midnight snack, a burger. And back in the hotel room, a very close encounter with the toilet bowl. Let's call it the transaction. So as you know, the single-touch attribution models would say that, for example, last click or last touch attribution, the midnight snack is guilty, the guilty one. That's the one causing the transaction. Or maybe first touch, the cocktail hour. Maybe you should skip it because it causes the transaction. But I think we all know and feel that this isn't right. Yeah. So we decided that it's probably a mix, a combination of all those touch points, and also a certain sequencing in the touch points that decides on whether or not the attribution, the transaction is going to happen. And that's why we decided on using a Markov model. So it's actually an attribution model, multi-touch data-driven, based on Markov chains, which is a mathematical concept, pretty complex, but bear with me. It calculates the probability of transitioning from one state to another. by calculating the removal effect of a certain touch point from a customer journey. So it has a big set of historical data on customer journeys. It takes out, with the removal effect, it calculates the removal effect of taking out one touch point, and thus calculates the value of each touch point within the journey going to no conversion or a conversion. And it does this with a very high granularity because it's on a touch point level. So if we go back to our customer journey of tonight, ladies and gentlemen, one example of an outcome of a Markov model would be, it's just purely fictional, but that the tequila shot had something to do with it and is more responsible for the transaction and thus gets a higher transaction value. So I think everybody gets it right now, by now. And just for the real geeks, this is what the Markov model looks like under the hood. These are some calculations it makes, so it's a pretty complex thing, but yeah, we've managed to make it work for us.
Right, Halewijn mentioned geeks, so let's stay to the geeky side. It's time to get to the most sexy part, the technical stuff. Any one of you already familiar with Google Cloud, with the services in Google Cloud? Very few. I'll go over what we have built. It's based on Google Cloud. If it's too technical or too fast, please interrupt. I'll show the architecture of a solution step by step, first high level, and then I'll drill down to the most detailed images we have. This is an easy one, data input, modeling and activation. The modeling part happens in Google Cloud, activation towards the advertising platforms that were mentioned before, and then also to reporting and visualization tools. Data preparation, we all know there's no model or good analysis without the really fun part of data preparation. We don't use AI for it, so we still do it ourselves. Basically, what you see here is an extract of the data that we use for our model. It's based on GA4 nowadays through BigQuery. So BigQuery is basically a raw data warehouse of the GA4 interface. You have everything on a row-based level and you can manipulate as you want. To remember from this is that we mainly extract traffic acquisition data, so channel, source, medium, campaign, ad ID, keyword, and even Google Click ID or gclit, to be able to prepare for every level of granularity. We include sessions that convert and don't convert, and we prepare this for journey stitching. On this slide, you can see the stitching happening. What we do is we take a session and we have a look back window. We have taken 45 days, and basically you have a session and you look 45 days in the past, how many other sessions does the user have, and you try to stitch it together. For example, the second row it's not a clear example because it's really a lot of text, but you see SEM, so you have a Google paid search session, you have a campaign, something about Gran Canaria, and then you have a Google Click ID. It's being followed by a direct session, and then a CRM session, and I guess that's all on the journey. So yeah, so paid search, direct, and CRM. You stitch this together, and then you create a full data table on the non-converting parts, because you see there's no revenue and transaction attached to the user. The same happens for the converting parts, so really the same, but only a transaction attached to the user. And then you have this full data set as input for the Markov model. This is an example of every service we use from Google Cloud. I won't go into too much detail on every service because this will follow later on. But the most important ones are Cloud Functions and Scheduler, then logging, because of course you need to have logs about your process. PubSub, this is a messaging middleman between every service. And then you have the output that goes through the advertising channels through an app engine and a compute engine. This is basically the most technical stuff in Google Cloud that we use. And this is a simplified version of the process. On the left, you see a scheduled cloud function. This is basically some code that starts and stops our process. When the process is being started, there's a compute engine or a virtual machine that is being activated. This contains an R script. We have the same in Python, but in this example we use R. And then within the script, the modeling happens, and the output is being pushed into the advertising platforms and our reporting analytics tools. The compute engine in the middle is being wrapped into a Docker layer. I will touch Docker later, but this is some orchestration tool that is really handy, but I'll show it later on. And then the entire process is being orchestrated by logging and PubSub, which is basically a messaging service. So it's basically tools that we use to allow the services to talk with each other. For example, if the function starts the VM, there's a message being sent. The VM is started, so you can go on with the process. If this fails, you have a log, and then you need to find out why it fails. This is just an image on the function that starts the VM and stops the VM. You get the slides, so I will just skip this. And this is the second part of this function. So it's scheduled to start and stop. We do this to limit costs and to stay cost efficient, because if you keep the engine running all day, all night, costs will inflate. And now it only stays active for about a minute or so, so costs are quite limited. And it's scheduled by a cron expression. We have a lot of machines. There's one for every source market. So Belgium, Denmark, Finland, Sweden, UK, and so on. So there's basically one for every market, and then one general one to do a backfill. Sometimes Google has a delay in processing the data. So then, of course, we don't have data to do the modeling. We have to do a backfill, and that's one general one for every source market. This is the setup of the VM. Also a lot of technicalities, but the most important ones is the machine configuration. So it has to have enough computing power, yet be cost efficient. We in Europe are quite strict on location, so we have to make sure the data stays within Europe. So we can't have the machine be in another continent. And then, of course, authentication is also very important. So those are three things that we focus on in our setup. Then some snapshots of the code that we use. You just see on the fourth line Markov model. So this is a modeling that happens over here. And we do it on a channel basis, so the highest level. We have the same snapshot on the other levels. So on source, medium, campaign, ad ID, keyword, and giglit. And then these insights are rolled up into a really holistic overview, and then you can really drill down to the bottom line that you want to see the insights on. This is a simple output that we get from the model. On the first one, you see channel group and source medium, and then you have last click as reference. It ain't really a reference, but just to be able to compare. And then you have the Markov values next to it. Over here, the same, but then with campaign as a second dimension. And then, in fact, you can add keywords, click IDs, ad IDs, just as flexible as you want. This is some code that we use to push this output into our platforms. This case is for Smartly. It's a European company that is quite linked to Meta. So we use it for paid social. And basically what you see is an API call where we push our output data towards the platform. And then the marketeers can use our data in their platforms to do real-time bidding. Platform agnostic has been mentioned because any partner that can accept an API call can be coupled to our process. This is, again, some code, not too important, but we just manipulate our output and we push it into the analytics systems so that we can do a deep dive analysis on the results and we can include it into Looker for reporting. And then these are two snapshots of outputs that we push into the advertising platforms. The top one is for Smartly, and the bottom one is for Google Ads, because you have the Google Click ID, so they have quite some frameworks on how you should input data. So we just manipulate our output so that it fits the requirements of the vendor. Two things that I haven't touched are security and then container application development. Security, so this entire process has an URL, so we need to be able to authenticate. This happens through a service account. It's basically an email address in Google Cloud that is used to make authorized API calls. And it passes on the authentication to every service being used in the process. So if you give that service account email address access, then that access is being saved throughout the process. As mentioned, we have requirements on data storage and location and processing location, so it has to stay in Europe for us. And we have some HTTP and HTTPS firewalls. On the right, Docker. I mentioned that this entire process is Dockerized. Docker is a tool that packages the entire solution into a standardized unit. We call it container, and it has every dependency, every library, every tool that we use. So basically, it allows our solution to work on every operating system, for example. A nice example is, we come from Belgium. If we come here, our laptops, phones, tablets, they don't charge in your power outlets, so it's quite a pain in the ass for us. But we have these small adapters that take every charger input, and then it fits into the power outlets. So this is what Docker does. It's basically an adapter for every operating system. And now, so far, I've only mentioned AI, that we don't use it in the data prep part. It's quite maybe offensive towards AI. Definitely, if you look at the other presentations, we have to use it. We do use it. Some examples: we use Gemini and ChatGPT to explore the complicated logs. And if you have any coding issues, then Gemini is also the first point of contact.
Yeah, actually the model itself uses machine learning, and we have been using the model for 5 years, so you could say that we have been using AI long before it was cool. Then, yeah, the business value, what do we get from it? It's pretty important to get your business stakeholders in such a project. So let's get back to our requirements from in the beginning. So a combination of multiple data sources, that's a check. We've seen in Martijn's slides that we could get the web data, but also CRM data, business data, pricing data in it. Data-driven, yeah, it's based on Markov chains, so I guess it's pretty data-driven. It's an end-to-end solution, so yeah, we have everything from data collection up until the activation entailed in the solution, with very much granularity, different layers up to the click ID, up to the touch point level. It is fully automated, so the data collection, data cleaning and prepping, the analysis itself, and the activation in the marketing channels and reporting tools, it's all fully automated. And we're connected across all marketing channels, as Martijn mentioned, that have an API connection, which is pretty cool, and actually got us to win the Best Use of Performance Marketing Award in Europe, so pretty proud of that. And the real benefits for us, first of all, costs. This Markov model optimizes our budget allocation over all our marketing channels. And it's the tool that helps us decide where to spend our next euro or dollar or whatever. Also, the model itself, the costs of the cloud services and all, it's pretty limited. So it's definitely worth it. And we've calculated that actually the marketing costs per sale has diminished by 20% by using this model, which is a huge win in efficiency. Getting to efficiency and flexibility. It's fully automated, super stable, and completely platform agnostic, so we are not depending on any big platforms for their attribution. And the process of modeling actually takes just about a minute. which is really quick. And an important part also is that we educated our digital marketeers on the data, on the output, on how the model works, so that with those easy and small questions, they can work it out themselves, and they don't have to come to us, which saves us a lot of work. And we've also calculated, actually, if we were to run this model all manually, it would take 1 full-time employee. So we saved 1 full-time employee. We didn't fire anyone. There's work enough for everybody, but yeah, that's just a calculation. And effectiveness, yeah, we believe this is as close as we can get to real-time bidding on our own source of truth, on our own compass, as we mentioned. And of course, we limit our media wastes enormously. So what's next? Yeah, we're like to think on how we can optimize the model and to improve the model. And there are a few challenges, of course. The complexity, this ecosystem is changing rapidly, and they're making it pretty hard on us to keep our model working. For example, we had to switch last year from GA360 data as an input to GA4 data. Let's not get into it too much, but yeah, it was pretty complex, but we managed to do it, so it still works and it's up and running. Then, of course, the privacy laws and browser restrictions make it harder on us to gather data. And the walled gardens of Meta, of Google, we don't know how much longer they will let us do this. So for now, it all still works, but we're very aware of these challenges. And the last one, yeah, is maybe an answer to these challenges above. We've streamlined our multi-touch attribution with MMM to be less depending on this deterministic data. And we've added incrementality testing also as a layer. So yeah, those 3, I don't know if you noticed, but multi-touch attribution, MMM, and incrementality were also the 3 pillars of our measurement framework in the beginning. So I think we've come full circle. And we hope you enjoy the flight and your attribution hangovers are cured. We're not responsible for the hangovers you have tomorrow. Thanks a lot for your attention.